So here is another question on electric potential. It is given that a region in space is specified by the potential function V is equal to 2x square plus 3y cube minus 5z square. Calculate the electric field strength at a point defined by the coordinates 2, 4, 5 xyz coordinates in this particular region. Okay, so here you have to understand the basic definition of electric field, okay, in terms of potential gradient is dV by dr minus dV by dr, which is negative potential gradient, that is the electric field. Okay, so when we are talking about a potential function, okay, here the electric field is given by, it is a vector, by its respective x, y and z components, that is Ex I cap plus Ey j cap plus Ez k cap, where Ex, Ey and Ez are the x, y and z components of the electric field. So here Ex, the x component of the electric field, that is given by minus del V by del x, that is partial differentiation of the potential function. Similarly, the y component of the electric field is given by del V by del y, partial differentiation of the potential function with respect to y, here with respect to x, and Ez is given by minus del V by del z, the partial differentiation of the potential function with respect to z, where z is treated as variable and others are treated as constants. Here x is treated as the differentiable variable and the others are treated as constants, like that. So here first we have to calculate Ex, Ey and Ez, the respective x, y and z components. So Ex is equal to minus del by del x of 2x square plus 3y cube minus 5z square. So everything else is constant, so only with respect to x, that will be equal to minus 4x. Similarly, Ey minus del by del y of 2x square plus 3y cube minus 5z square. So only y part will be differentiated, others are constant, so it will be 0, so it will be equal to minus 9y square. And similarly Ez will be equal to minus del by del z 2x square plus 3y cube minus 5z square. Only the z portion will be differentiated, so it will be equal to 10z, minus minus will become plus. So Ex is equal to this much, Ey is equal to this much, and Ez is equal to this much. So the electric field is defined by minus 4x I cap minus 9y square j cap plus 10z k cap. Okay, so the electric field at the point 2, 4, 5, that is x is equal to 2, y is equal to 4 and z is equal to 5, that is given by minus 4 into 2 I cap minus 9 4 square j cap plus 10 into 5 k cap. So that will be equal to minus 8 I cap, then it will be equal to minus 144 j cap plus 50 k cap. This is the electric field at the point 245 in the region defined by the potential function V is equal to 2x square plus 3y cube minus 5z square. Okay, so this is the thing. So always remember all the respective formulas which are related with one parameter to the other. So the relationship between electric field and electric potential in terms of potential gradient, that formula came into use here. Okay. So here is another question. It is given that two electrons, each with a velocity of 10 to the power 6 meters per second, are released towards each other. What will be the distance of closest approach? Okay, so what this question actually means is that we have two electrons, one from the left side, okay, this electron 1 from left, and another electron 2 from the right. They are released towards each other from far away with a velocity of 10 to the power 6 meters per second. Same here also, same 10 to the power 6 meters per second. So at this point, okay, at this point their velocity will be maximum just after the point where it is released. Kinetic energy will be maximum, max. So as these electrons, they keep moving towards each other, okay, they keep moving towards each other, their velocity will start decreasing. Why? Because both of them are negative charge, okay, same magnitude, so they will experience a force of repulsion between them. So as the distance between them, the separation distance between them starts decreasing, their velocity will start decreasing as they move more near and near, closer and closer towards each other. Then will come a point where both of them will finally stop, okay, they will stop when the force of repulsion will be maximum, they will finally stop. So let's say the point where they stop, that is at a distance r from each other, the separation distance is r, let's say. So here at this point where they stop, the electrostatic potential energy between them, the potential energy between them, that will be maximum, okay, that will be maximum, and the kinetic energy will be equal to 0. Kinetic energy will be 0 because they have stopped momentarily, then they have stopped. So here potential energy is 0, okay, potential energy, here potential energy is 0. At the start only kinetic energy, when they stop only potential energy. Now we know, according to the principle of conservation of energy, at each and every point, okay, the sum of kinetic and potential energy will be constant for both, for this two charge system. The sum of kinetic and potential energy will be constant. So for this two charge system, okay, for this two charge system at the beginning, okay, at the beginning the velocity is how much? The electrons 10 to the power 6 meters per second. Mass of electron, that is equal to 9.1 into 10 to the power minus 31, okay, kg. So the mass is 9.1 into 10 to the power minus 31 kg. So for this two charge system, the total kinetic energy, that will be equal to the kinetic energy of both the electrons, that is 1 by 2 MeV square for electron 1 and then again 1 by 2 MeV square. So that will be equal to MeVe square, which is equal to 9.1 into 10 to the power minus 31 into 10 to the power 6 square, which is coming around 9.1 into 10 to the power minus 19 joules, okay, this. So this is the total kinetic energy of the two charge system at the beginning, just after the point it is released where the velocity is maximum, okay, just at the start, at the beginning here, at the point of release. Then at this point where both the electrons, they have stopped momentarily, the potential energy is maximum. So the potential energy at that point will also be equal to how much? The total, the potential energy of the two charge system, that according to the principle of conservation of energy, that should also be equal to 9.1 into 10 to the power minus 19 joule. Now we know that the formula for two charges QA and QB separated by a certain distance r, the potential energy for this two charge system, that is equal to 1 by 4 pi epsilon 0 QA QB by r, okay, this is the thing. Now here it will, for the two electrons, the potential energy will be equal to 1 by 4 pi epsilon 0 QE square, that is electronic charge by r. Now we want to determine this r, that is equal to 9.1 into 10 to the power minus 19. That implies nine into 10 to the power 9 into 1.6 into, sorry, here it is 1.6 into 10 to the power minus 19 coulomb square, okay, this is square, by r, that is equal to 9.1 into 10 to the power minus 19. That implies r is equal to this much, this will go here, and this 9.1, that will come in the denominator. So this r is coming around, this will go into the denominator, r will go on the RHS side in the numerator. So this r is coming around 2.56 into 10 to the power minus 10 meters, this much, okay, 2.56 into 10 to the power minus 10 meter. This is the value of r. So the distance of closest approach, it means the point, the distance between the two charges where they will come to rest momentarily. So here the potential energy will be maximum, and as they have come to stop, the kinetic energy will be 0 because velocity is 0. At the point of release, velocity is maximum, hence kinetic energy is maximum, potential energy is 0. As they keep moving towards each other, they experience force of repulsion because they are like charges, negative charges. So gradually the velocity starts decreasing, kinetic energy starts decreasing, and this decrease in kinetic energy is stored in the form of potential energy. So as they move forward, kinetic energy starts decreasing, potential energy starts increasing. Okay, this for both the electrons. Okay, so this is the thing.